Well, hello, everyone. I have the time now as on the hour for us to begin day 2 of our 23rd International DSM Conference. Welcome, everyone, especially those who are joining today for the first time. We had a pretty good session yesterday, I thought, and I hope you agree, those of you who were there. Welcome to today, where we've got some exciting presentations in store, including a keynote session again. We're going to begin in about 15 minutes with our first session of scientific, industry, and student papers. And then we will have our break for networking. We will have a keynote presentation thereafter, followed by another break. And then our second session, both of the sessions today are titled Product Architecture, meaning that they will predominantly feature DSM applications of products being modeled. However, sometimes we get some miscellaneous things in there as well, but that'll be our general theme. So please take advantage of the networking opportunities between the sessions as well. And please look forward to asking questions at the end of each session to our presenters. We're again thankful to Polytechnique Montreal for hosting us, even if it's mostly virtual for most of us. They've put a lot of effort into planning, and we've also gotten tremendous support from TUM, Technical University of Munich, and especially Jakob. So thanks to everyone there. Jakob, if we go on to the next slide. Maybe you could go over this one better than I could as far as our protocols for the day.
Yeah, I will do it very quick because I did it already yesterday. Just for those who didn't join us yesterday, we have all Zoom links entailed in 4 waves. Our conference platform, where you also registered. There you can find the schedule where you have all the links. And we always have 1 link per session. So if you want to join the next session, just click on the link. You can stay in the room until the last event. Then the room closes automatically and you need to pick the next link. For the breaks and networking, we're using Wonder. That's a different platform, but it's the same. Just click on the link in the schedule and the window opens and you can have nice chats in a networking room. For the questions, especially today during the paper sessions, please use the Zoom chat. You can just post your questions in there because we will have all presentations one after another and then a discussion session at the end. And the session chairs, Tyson and Pascal, will then queue up those questions in the discussion later on. Okay. Otherwise, the standard rules for Zoom meetings, please make sure you're named correctly so we can see who you are. Feel free to turn on your camera. I think that's nice to have some smiling faces on the screen and not just your slides. And make sure to mute your microphone during the presentations because otherwise we have disturbing noises. And to applause, you can use the virtual clapping, of course. I said it earlier today already, we are using Mentimeter today in some occasions. So if you want to participate in those live polls, you can click on the link, which is now in the chat. You should all see it. Then you're directly in, or you can also use your smartphone and scan this QR code here. We will show you what we can do with it in a couple of seconds, I guess. And later we will use it to vote for the best student presentations. Okay, that's it from a technical side. If you have any questions, problems whatsoever, let me know. You can write me an email or reach out to me in the chat. I will be here all day. Back to you, Tyson.
Thank you, Jakob.
Welcome.
All right, so next slide, or do we move to Menti? Okay, Very good. So we need to click on that link that Jakob sent us. And when we do that, we get a brief, simple survey where you are asked, how did you like the first day of the conference yesterday? So please give us some feedback. You can rate it, sliding from left to right. And if you liked it a lot, you get all the way over to the right. We had a tutorial, we had a keynote on the Canadian ventilator design and production in record time. We had maybe 4 presentations by tool vendors with some exciting developments about how those tools have matured and evolved for project management, systems engineering, software architecting, and other applications. So good to see those votes coming in here. It's interesting how it updates real time. I should go and add my own vote as well. The bottom right corner here shows us how many have responded. Looks like we've had 12, 13 respondents out of 31 participants logged in. So let's give a few more moments to let everyone find this link and enter their votes, which won't take too long. It looks like the breaks and networking could stand some improvement. And I have to say, I enjoyed the one of the 3 that I got to go to and participate in yesterday. But I think we would all get more out of them, the more of us that show up and participate. So I think the tool worked pretty well once I saw how to get more than 5 pictures on the screen at once in Wonder. There was a little button in the upper left corner with 2 arrows on it. When I clicked out, I got to see everyone in a group at once, and that was better. So hopefully you've tried Wonder, you've learned how to navigate around there, and I think our breaks will be exciting when we get more of us talking in there. But we had a good group of 7 yesterday at the end of the conference that went really well. Okay, we're up to 20 responding so far. So we'll give a couple more moments. Jakob, I don't know if this will continue to be available once we move on, but if so, we can let people keep voting.
Not this question will be available then anymore. We move on to the question, but we can already do.
So we really do need to answer it now, or we lose our chance.
Yes, but I think we can already move on.
All right. Okay, well, this is pretty good feedback, so thank you very much for responding. Next, we have another opportunity also in Menti for you to add any questions that you have from yesterday. I don't know if yesterday answered all your questions about DSM or if it just provoked new ones. So if you have any questions about DSM, here's an opportunity to enter some of them. If we don't have time to answer them now, we'll try to do so later at other opportunities. If you can't think of your question immediately, once again, you've got opportunities to enter questions in the chat boxes of our sessions, which will be left until the end of the sessions to be addressed by the presenters. But if there are general questions, then other ones of us could also try to answer. And then, of course, the networking breaks are opportunities to get together and ask questions directly to people. So we've got lots of opportunities for question and answer. Great, a question. When will the recording of each presentation be available? This is a good question for Jakob, probably. But if you don't know, we'll find out. Because I don't know the exact answer.
I don't either.
Usually Usually it takes Zoom a few hours,
Yeah.
sometimes a day.
Yeah, actually, I'm recording Zoom at our cloud server here, and we have them all, but we want to make some editing before we make it available. But so it will be available, but after the end of the conference.
Okay, good to know. And then a similar question we could ask, I should maybe put it in Menti here, just to make it official. How do we get links to the PDF versions of each paper that's presented?
Yeah. So for the paper publication, we unfortunately have some issues this year, but I think they will be published end of this week or latest next week. We will have the complete proceedings.
All right, thank you. That answers why I couldn't find the link.
Exactly.
Okay, any other questions? These can be technical about the mechanics of the conference, or they can be about DSM.
This question we can also leave open. So if you have any further questions, you can always put them in there.
Okay. Well, we've only got about 4 minutes until our session begins, so I'm not sure if we can answer this next question in 4 minutes. What are the most relevant advancements in DSM applications? Well, one answer to that question is simply watch the sessions today and tomorrow, because these are the current research applications and advancements, and that's exactly what the conference is about. However, maybe we'll be able to further answer this question at some of the breaks and other opportunities. So stay tuned for answers to this question over the coming sessions. All right, well, we'll continue to collect questions, like Jakob said. Meanwhile, we'll take a few extra minutes to move over to our first formal session of presenters today. And I would like to introduce the chair of this session, Pascal Eitman. Welcome, Pascal, and I'll hand the ball over to you.
Well, thank you, Tyson. And let's then move on with this first session. And I would like to welcome everyone to this session on the Product Architectures Part 1. And we have for this first session 3 scientific presentations, 1 industry presentation, and 1 student presentation. And I would like to ask the presenters to try to stay within their allotted time. So that's 12 minutes for the scientific and industry presentations and 8 minutes for the student presentation. And as Jacob already announced, the questions will be addressed after all the 5 presentations have been given. So the audience, we would like to ask, please post your questions already during the presentation in the Zoom chat. And we would appreciate if you do mention in the chat, in your post, the name of the presenter, followed by your question. Then it's for us easy to collect the questions. And even if you have a question that pops up after the presentation, then simply mention the name of the presenter and include the question. Well, it's almost 16:15, so I finished this introduction, and I would like to give the floor to Julian Kreis, who is the first presenter with the presentation on methodology for structuring and bundling product surface systems. Please, Julian, if you can connect and upload the presentation for us to view, and I would like you to give the floor.
Perfect. Thank you very much for the introduction. Welcome to my paper presentation. I hope that you can hear me as well as that you can see my screen. My name is Julian Kress and I'm a research associate at the Laboratory for Machine Tools and Production Engineering, which is located at the Technical University of Aachen in Western Germany, close to Cologne. The title of the paper is Methodology for Structuring and Bundling Product Service Systems. With the aim that we would like to bundle different parts of the product service system to PPS bundles to provide them by different stakeholders in a corporate value networks, so that you are able to provide the PPS together with partners in a value network. So what was the motivation for our research here? Especially in the engineering and in the mechanical and plant engineering sector, these companies are offering product service systems a lot these times. So what are the reasons? I have brought you some reasons here on the left side. We have, of course, an increasing competitive pressure, especially from global manufacturing companies. And the problem for companies in Western societies is a little bit that they have no additional space for technical differentiation, because they are reaching step by step the physical limits of their products. Therefore, they are seeking for different opportunities to differentiate from competitors, and there, of course, add then different services and form product service systems. So in the future, there will be selling solutions instead of singular products. But when you're offering product service systems, you have the problem that you are not able to provide the product service system just on your own competencies. So you are relying on different partners with complementary competencies so that you can provide these solutions in terms of the product service systems. Therefore, the aim of the paper is to bundle or to define these PPS bundles so that you can provide the whole PPS together with partners. Therefore, we are aiming for structuring the PPS by a decomposition and the definition of a PPS architecture. We are also figuring out how we can bundle, or how we can define the PPS bundles consisting of product and service components, and that we also consider the independence between the different PPS bundles, so that it's possible to provide different parts of the PPS by different stakeholders. And therefore, we are aiming for development of a methodology for determining PPS bundles to provide the whole PPS together with partners in a corporate value network. We also had a look at existing research. So here's an excerpt of a list of the approaches we have checked. So for example, we focused on approaches which are mainly focusing on products, approaches focusing on the service dimension, as well as the combined considering of both dimensions, the product as well as the service dimension. And in a nutshell, you can say that there is no systematic structuring of PPS and holistically consider both dimensions, so the product as well as the service dimension. And we would like to, of course, bundle these PPS components to PPS bundles and also consider the interdependencies. Furthermore, there's a lack of consideration of necessary competencies to decide as the PPS offering company which parts of the PPS you are providing on your own and where are you relying on partners, and where you have where you need support to provide the PPS. So here's the overview of our methodology, where you can differentiate between 5 successive submodels. And the first step, 1 and 2, is structuring of the PPS. So at the top, you have the functional structure, then the product structure, as well as the service structure. In a third step, you have to identify the interdependencies between the three dimensions, so the functional dimension, the product dimension, as well as the service dimension. The fourth step is focusing on the definition of integrated PPS bundles, consisting of service components as well as product components. And in a last step, we would like to visualize the interdependencies by an integrated PPS architecture, where you do not have on the product side not a separate product structure as well as service structure, but instead that you have an integrated PPS structure. So let's have a look at each of these 5 steps pretty quick to give you an overview. What are the ideas behind it? First, you have to define the extent of the product service system. Therefore, we are using the value proposition canvas of Osterwalder. So because you are aiming for a customer-centric product development, therefore you start with the job to be done, identifying different pains and gains, as well as gain creators and pain relievers, and then you have to define, as the PPS offering company, which products and service components you would like to integrate. Therefore, as a result, you have the requirements for your PPS, more or less the functions, as well as the different product and service components. Furthermore, we would like to structure the identified product and service components. Therefore, we would like to use the product architecture approach, which is a common tool for structuring products. The big question is it also possible to transfer this or to use this methodology also for the service dimension? And we did an analogy consideration, which we also have explained in detail in the paper, where we discussed different arguments for and against the use of the product or the product architecture approach also in the dimension of services. And as a result, we came to the conclusion that it is also possible to really break down different services in their different, like we call it service components, so different process steps, different sub services, etc., to also structure services in an hierarchical way. Therefore, you get this PPS architecture, where you have here on the product side, on the left, the product architecture, on the right side, the service architecture, and both so the product components as well as service components fulfilling the different functions and sub-functions of the PPS. But it is still not an integrated visualization here, because you do not know the interdependencies between both dimensions, the product dimension as well as service dimension. So this is also the linkage to step 3, where we used a multiple domain matrix, consisting of different design structure matrices as well as domain mapping matrices. So first, here in the yellow area, you can use now the different functions to really figuring out the interdependencies and evaluate them with this 3-step scale here. And then that you also identify the interdependencies between the product components as well as service components, together fulfilling the functions of the PPS. And then here in this greenish area, you have to evaluate the interdependencies between the product and the service dimension. So after you have identified the interdependencies between all 3 dimensions, the next step is the bundling of the PSS components into the PPS bundles. We have used an IGTA plus cluster algorithm instead of the classical IGTA cluster algorithm, because the biggest disadvantage is that you have a variation in the results in the classical one. Therefore, we use the plus one, which has additional benefits here, which I have listed here and don't want to explain in detail. So this is also the linkage to step 4. So we did here the bundling so that you have identified that you can identify the PPS bundles, and to make sure that there are, or that these PPS bundles are as independent as possible from each other, so that it is also possible to provide each of these PPS bundles by a different partner in the corporate value network. So, and as a last step, because you now know the interdependencies between mainly the service dimension as well as the product dimension, you can also elaborate or define an integrated PPS architecture, where you have on the top, of course, the different functions of the PPS as a common denominator between both dimensions here on the product side, and that you can define now here the PPS bundles with the different components, where you have an integrated view and not a separated view, where you have the products separated from the service components. We have also applied this in a use case where we used an operator model of a manufacturer of compressed air. They're normally offering compressors in the past, and in the future they will sell compressed air instead of the compressor itself. So they will sell the cubic meter compressed air for a fixed price. So if you now check the different PPS components, so the product components as well as service components, you can then apply the interdependency matrices as well as the IDGA cluster algorithm to define different clusters. And there you can then define the PPS bundles. For example, there you have a bundle where more or less financing topics or components are collected to a bundle, or where you have here in bundle 2, for example, the controlling and sensoring system as well as performance monitoring as an additional bundle, which can be then provided by a different partner in the value network. So this is more or less the overall idea, and I would like to sum up my methodology here. So we have created an PPS architecture in analogy to the product architecture. It is a low effort for defining the PPS bundles consisting of PPS components, so product components or service components, using the IDGA plus cluster algorithm. We would like, or it is possible to support with this methodology, the collaborative provision of the PPS, so that you then, as a next step, can decide which PPS bundle can be provided by which partner. And this is also the linkage to the outlook. So as a first topic, we would dig deeper in the determination of interfaces between the product and the service dimension. Furthermore, we would like to integrate the competency dimension also in this methodology, to really figuring out which competencies are necessary to provide the bundles, and then to select suitable partners. And as a third step, that we bring this into a big picture, so to design the corporate value network based on the competencies and strategic topics here from the perspective of the PPS offering company. Thank you very much. I hope I stayed in time. It was quite a rush, but it's pretty sporty to stay in time in 12 minutes. Thank you very much.
Thank you very much, Julian. Let's give him a virtual hand. And in the meantime, if you have any questions for Julian, please post them in the chat. And then we move on to the second presentation for this session. It's an industry presentation by Han van Roosmalen, and the title of his presentation is DSM for Data Warehousing. Han, can I give you the floor? Is Han present?
is there, but he's muted.
Yes, I'm here. Yes.
All right, excellent, Han.
You hear me? Okay, that's good.
Can you share your presentation with us? And then
Yes, I can. I'll share screen. One. Here.
so if you have any questions for Han, please post them in the chat, mention Han and the question.
Yes, like this. Okay, welcome. My presentation will be less academic than the others I heard so far. And the applicable area is also a bit different. I'm a software engineer, modeler, etc. And I use DSMs and modeling tools quite some time now, and the combination I like better. And that's what I want to demonstrate in this this presentation. Currently, I'm working for the Nederlandse Spoorwegen, the Dutch railways in the Netherlands. And yes, they do something with trains, nationally and internationally. They do something with bikes. They host the largest bike garage in the world. They do something with car sharing, and they have some railway stations. At the bottom, you see the railway station of Utrecht Centraal, which is the main hub in the Netherlands. If something fails at Utrecht, then all the other trains will not run. And the other one is a new station at Rotterdam Central Station. And beside that, on the stations, they have some shops that they also run. So they do more than just transporting people. What I like to talk about right now is what's a Dutch railway for a kind of company, and what is the area that I'm working in. How do we work in the data warehouse department? I will show you some output of the data warehouse so you can get some feeling of what it provides. Then I discuss some improvements that we want to make in short and long term, and I will show you how the DSM is helpful in what we are trying to achieve. The Dutch Railways is the largest people mover in the Netherlands on a daily basis, and not taking into account the COVID situation. 2 million people are transported from one end of the country to the other end. They hold a share in Albelio in the UK, so they're not only Dutch railways. They are in operation since 1917. It's good to know that the Dutch railway infrastructure is not maintained by the Dutch Railway, but by a company called ProRail. And we have one of the most dense railway infrastructures in the world. As you can see on the map, here you see all the lines that the Dutch railway company is supporting. Within the data warehouse department, it's called the DIA department, that stands for Data Information and Analytics. There are over 200 people working with the data warehouse, of which about 30 plus are modelers. We have to open up more than 50 different data sources, so say more than 50 databases into one enterprise-wide data warehouse. In the future, in the past, there were several business units at Dutch Railways, and they had their own data warehouse system, but management said, well, that's too costly and we want to combine information, so we have to have one data warehouse. And the data warehouse should be in the cloud. Today that was not very successful, but normally that runs pretty nice. And we want a reduction of the overall operational cost and efficiency, which is very important. The only sector in the company that receives some investment money is this project. And you can imagine that there are over 200 people, so my contribution is only a very small part of that, and I have to improve the model management. So I have to make sure that the model that those guys are making will be better tomorrow than today. For the people that don't understand the data warehouse, it's a different kind of a system. It contains of data sources from operational systems like SAP and ERP systems, etc. They are the data in there is transformed into the data warehouse database, and then it is moved to data marts, and then you can do your analytics. Well, this is a very simplistic view of the situation. If you have a large organization with a large data warehouse, this is a bit more complicated. What do we do right now? We use Spark Enterprise Architect as a modeling tool for holding the business data models, the business data objects, which is about around 1,500 objects. Those are transformed to the logical data model, which are a multitude of those objects, and we expect to have over 500 diagrams holding just the logical data model. Then we come to the data warehouse. Then we have business and raw fault data, which is a multitude of those logical data models and even more diagrams. And then we make the data marts, which will hold maybe less objects than the business data fault, but still a large number of diagrams. The data is transformed or used by information products, and we have over 100 of those information products. That's only the structured part of it. There's also an unstructured part of it. You can imagine that you receive sensor data from railway stations, from trains on the road or on the rail, etc. And those end up in the data model as well. And that leaves that all those data combined ends up in various business intelligence dashboards, which are run in Power BI. And the data warehouse is currently stored in Azure in the cloud, Microsoft SQL Server. But we have over 5 million real-time users. In the Spark CA model, we model the data, but we also generate the create scripts for the data tables in the data warehouse. So the data model should represent the data in the data tables. This is an example of the data warehouse output. Here you see a planning tool, which I can, I live in Deventer and I want to go to Amsterdam Central Station. Then I enter the departure date or the arrival time. And then I get up-to-date information on what train is leaving where. And you see the red numbers here. That means that delays are on those trains, on those tracks. That's pretty nice to have, but it becomes even more interesting if you know how many people are expected to use that particular train. And that data is not only coming from a planning tool, but also from sensor values from the carriages of the train, historical transport data. So there's a history on this time schedule for this train going from Deventer to Amsterdam Centraal in historical data. We do some checking by stochastic measurement, and of course we have the actual card scans that people have to scan their cards when they enter the train. What's also important, and that's also a business intelligence information, is that we should be performing better than 89% in-time connectivity. Otherwise, the Dutch railways receive less money from the government. The data is all stored, is all coming from the data warehouse. Okay, what's in the data warehouse? I said there are some different models, and you can see those models. There's this business model, there's a logical data model, a staging model, a data vault model, and a data mart model, and an information product model. And there are many of them. And what you see is that we have to order them to business domains and teams within those business domains to make this easier to understand. So what do we want to achieve? We want to open up all relevant IT sources, so all databases that are relevant to provide information for the data warehouse should be opened. In the meantime, we want to switch from Microsoft SQL Server to Snowflake, which should perform better for that number of data. All the data warehouse tools should move to the cloud. You can imagine that it holds a lot of privacy information. So the security should be as high as possible in the data warehouse. We want to deploy new instances of the data warehouse in a shorter amount of time. We expect that the number of modelers will increase to up to 200, so maybe more. We will open up the model for stakeholders that are not modeling. There are more people interested in the data model than only the data modelers. And we want to provide the possibility to have data ownership at model level. Right now, we just have an Excel list of people responsible for a certain business object, but we should change that and bring it into the model. And beside that, we want to have a business intelligence data dashboard for the model state, for the information in the model itself. So we want to have insight in the information, the current state of the information products. How complete are those information products? Well, to achieve this, I have a couple of headaches. How do I get and keep oversight of the current state of the complete model? And how can I make people pointing in the same direction? Well,
Han, would you be able to continue to finish in let's say 2 to 3 minutes?
Yeah, I can try. Okay.
Thank you.
We make the models in Spark Enterprise Architect. I make an extract from that. I put it in Analytics DSM. And in the future, we like to have the Analytics web interface to show the information that I will present shortly. And the information of the DSM will provide feedback on the data ownership, the model inconsistency, and the progress of the developed pre-production and production situation. Well, this is how it looks like in the DSM. Here you see of one team, you see a number of data tables and their interdependencies with other parts. And the interesting thing is that you can drill down and drill up in those in those areas and see how elements are interconnected. So here I see the dependencies between the data tables, and here I see the interfaces to the data from the data tables to the other areas. So what are we going to achieve? Right now, we have one part of the data model or the model that holds most of the data tables, and we are moving those data tables to the various domains, domain clusters, and you see that there are 3 teams that have already moved, and that means that this shows how the model evolves. We want to achieve a lot with this, and the ultimate goal is to achieve model versioning. And model versioning is one of the most complex things in modeling, because you can imagine that some data models are complete, some data models are in work in progress, and some data models are still to be developed, and you want to branch, like you do in software, to continue on modeling. Every 3 weeks, I do a snapshot of the repository, and then you can see what's happening. You can see that there are more teams moving from this area to that area, so they reposition their data tables and diagrams there. The number of traceability items are increased, so that's good as well. And I also see that some teams are not working as I want to have them work at the moment. When I go into the model, I can see, when I drill down into the DSM, I can see that there are tables in development. So we record the user story sprints, and we have the tables that are in production. So what I hope to see is that all the dependencies are here and there are no dependencies there, because then I know that all the data tables are in production. What's interesting in this combination of showing your model into a DSM tool is that it's very easy to get insight and oversight of large models. You can imagine, if I want to have the same information in that from a model, I have to look at thousands of diagrams, and then I'm lost in space. Just having a DSM is very helpful here. It helps me to determine at a higher level what the model quality is. And in other situations where I use this tool, I can see that it's very much helped, the DSM very much helped me during alignment with development, be it databases or software code. And it is easy to show the intended architecture versus the emergent design. The intended architecture in SparkCA and the emergent design in Lattice, and when I combine them, I can see very interesting things. And that's the way the Scaled Agile framework is hoping that people are working. And of course, I can use the DSM to start my refactoring scenarios for slicing and dicing the model or the code into other things like microservices, etc.
May I ask you to finish your presentation to also respect the other people's?
Yes. Well, I'm finished.
Thank you very much. Thank you very much. If you have any questions for Han, please post them in the chat. Thank you, Han. Let's give him a virtual hand clap. And the next presentation is by Jordan Tusuzov, and the title of his presentation is Interface Component Model as a System Design Tool for SE Toolset with DSM. Jordan.
Thank you.
Still on? Oh.
If you have a question for Jordan, please post it in the chat. Mention Jordan in your post, and that would be very helpful.
Okay, thanks. I hope you see my screen and you hear my voice. Hello, everyone.
Are we seeing Han's screen still?
Oh, really?
We see an Outlook screen.
Yeah, it's Hans' screen. Han has to stop and Jordan has to start sharing.
All right.
Han, can you please close your screen?
Yeah, how do I do that? Oh, okay.
Yes, thank you very much.
So now you see my screen?
Yes, we do. Thank you very much. You can move forward.
Okay. My name is Jordan Tosuzov.
Is niet wel, Frank-Jan? 12 minuten is niet zoveel.
All right, Han, you have to mute also. There you go.
Okay.
Yes,
So
please.
let's try again. Maybe the third time is for good luck. My name is Jordan Tosuzov. I am chief engineer at Vistion Corporation. So we are a company, OEM supplier, tier 1. But the work I'm presenting today is a private work, so not related to my company. I would like to present you an alternative method or additional method to DSM. So it's not exactly DSM, but it's very much related because it is a design matrix and it's a structure matrix. So I decide to try to present it here, and I hope it will be of interest. It all started, by the way, with DSM. I was looking for a way to have a view of the system architecture, which is understandable and readable for any stakeholder, and especially the ones who are outside of the engineering organization. And I will refer several times today to the great presentation of Dr. Browning yesterday. It was also mentioned there that the tables and the matrices are something which practically everyone understands. And if we look for a way to communicate system architecture, the matrices can be a very good idea. And I tried to use DSM at the beginning for this. And after trying to implement it kind of locally with some of our projects and some of our audiences, found several issues, let's say like this, which may be addressed in a different way. And this is actually how the interface component model or interface component matrix was created. So let's move forward. When we want to show a system, to have a view of the system, of course, it's very important to decide what of this system should be shown. And taking into account some of the most, let's say, common system definitions, for example, the one from Thinking in Systems from Meadows, we know that the system consists of elements and interconnections, and the function, which is actually its result, the result of the work of the system. And if we take the DSM representation, we see that we have the elements here, and we have the interconnections or relationships here in the middle. Yesterday, there was a great example, by the way, with this very, very complex, huge graph with overlapping relationships. And it was mentioned that from the lines, we cannot even see that some of them are arrows and there is a direction of these relations. But still, we see here the directions in the DSM, but we don't see actually what these relations are doing. And when we are reading the names of the components or elements, we can understand every single one of them, what it is doing. But we should not forget that the emergence of the system is often the result of the interactions and not of the components alone. And that's why looking at these representations, we cannot always understand why a system have certain emergence, because we cannot know what kind of interactions these are. And actually the ICM, so the interface component model or matrix, is listing both components in one, let's say in the columns of the table, and the interfaces or the relationships in the rows of the table. So this leads, of course, to a table which is not square, and we have listed both elements and interconnections. and both of them receive the same properties practically. Both of them gets their names and identity, which makes easier to understand what is the complete system structure. So the lines get names, and we can also understand, for example, that between the tuner and the amplifier here, there is this interface, which is an analog audio signal. So inside the table, of course, we put input, output, or input, output for bidirectional interfaces for everything which is linked with any kind of flow, like energy or information or material, commands. So everything which can flow, we can use this I/O and I/O, and this is equivalent, of course, to something which appears below, above the diagonal, or is symmetric in a DSM. So this is in the, let's say, the quick introduction what ICM is. I tried as much as I can to check if something like this already exists. I haven't found. Hopefully no one will tell me now that it's already long ago known. But this is how we create an ICM. I have tried with several stakeholders just to see what is the feedback, and it turns out that actually to understand the system described in this way, without additional information like some diagrams or something like this, is turning to be easier than if you look at the DSM. So this is how actually ICM initiated, but the DSM is still closely related with it, because both tools are matrix based, and the DSM is obviously the stronger part, let's say, of DSM is the analytical processing, like clustering and sequencing, while the representation and the readability of the system is maybe happening better with ICM. At least this is the feedback I've got since about 2 years since the thing is in use. But in the work, by the way, popped up 2 other aspects which I want to present. They are addressing the ICM, and when using DSM, I think it's good to know that something like this can happen. First, I try to enter internal ECU architecture. ECU is electronic control unit in automotive. To enter the ECU architecture of in DSM. It was before the ICM was, let's say, developed. And I came to this moment that in a situation like this, if we have 2 components with many different interfaces, which have completely different directions and purposes, if we translate this into DSM, we actually get this. Yeah, so the DSM we see here is the DSM representing this subsystem above in the left corner with 2 components and 4 interfaces. And actually, if we translate it back, or someone tries to understand how the systems looks like out of the DSM, it will look like this. So of course we lose here the name, but we have a sum of all these interfaces here as a bidirectional interaction, which when presented in the ICM is possible to be distinguished. That it's not one interface, but different, and they have different purposes. They may even appear in a different time. So we know that DSM and even the ICM is a kind of statical view. But for example, if we have something like this, of course, at the beginning by startup, it is the power supply which is coming, and still the other interfaces are not there. And depending on the functional decomposition, we need to take into account that not all interfaces are all the time present, and some of the features can or cannot work in every single moment in time. There is also kind of the opposite use case of that, and this is when we have an interface of type bus. So structurally in the engineering, it is very important to distinguish, and that's why the bus generally exists. It is to make the system scalable by adding additional nodes without increasing their complexity on the square principle. the complexity grows probably linearly, but not on a square principle. And if we try to represent a bus structure like this, the DSM will look like this one, which means that because every single bus entity can speak with any other, it is reflected here as a possibility, but it shows a system which is highly interconnected, like peer-to-peer connection from each node to each other one. And this is the DSM of both system 1 and system 2, so in the upper left and upper right corner. And actually it doesn't differ, even though obviously when we look at the graphs, it's not the same complexity of the system. And in the ICM, this is addressed in this way, where we can have one interface which is shared within many components. It's not only the information bus, and it's not something new. If you have a power line from which we have many consumers which are attached to this power line, it is also a kind of this big shared component interface, which is very important in one representation to be distinguished by peer-to-peer connections. By the way, in the paper, I don't have it here in the presentation, but I will switch quickly to the paper. I have used, instead of such a bus like CAN, for example, where it is really physically everything is linked to one cable, I used Ethernet because this explains. At the beginning, I found a kind of workaround of this situation, and it is to add the physical carrier of this interface as a separate component, like here. And by doing that, of course, we can reduce a lot this interfaces which popped up like peer-to-peer, and to show that actually the complexity of the system is lower than this one. But when we do really a system architecture, no one is really considering that the carrier of a bus interface is a component. So that's why it is a workaround, but it's not very nice. And in the design of the ICM, it is actually somehow naturally coming to this. If we come back to the definition, so what we want to show of a system. So we said, okay, the elements and the interconnections are together representing the physical system. But it is good to have link between this physical system and its emergence or functions. So that's why in the tool, which I hope I will have time to present, and it's a non-commercial tool. That's why it's not presented yesterday. Everything can be done also on paper. So it's not a big issue, but we can make a function to form mapping. So this is nothing new. It is just a domain mapping matrix which we add below the interface component matrix. But in the tool, it pops up that it's quite useful actually, because we can highlight very easy, for example, the minimum viable system or the subsystem which is implementing any feature. And if we make, of course, this domain mapping matrix together with the DSM, we will see also the components, but the interfaces will continue to be this axis or weights or whatever, but not this description. And in this view, we can see that the reception of the radio signal and playing over the loudspeaker, it is following this path, is this subsystem here with these components and these interfaces. One thing here, because I gave it for several peer reviews and there were questions, what is this 1, 2, 3? So it is a kind of modification of the domain mapping matrix. If we have a functional decomposition which is sequential, so it is that there is a path like the audio path here, we can mark it here like 1, 2, 3 is first the antenna, then the tuner, then the amplifier, then the speaker. This is the path of this function decomposition over the physical system. And we can also have some sanity checks, like that the output input is also the path of the interfaces is following the same sequence here.
Jordan, could you please finish in 1 or 2 minutes?
Sure. Okay. Then I cannot demonstrate with the tool, but here quickly I will show the link between the tool, the ICM and the DSM. So in the tool there is an algorithm which turns, of course, an ICM into DSM. So we can, after we model the system here, we can make, for example, the clustering. And without rearranging here the components, because we will never see these clusters here, the representation is different. We can make here in the domain mapping to define the clusters which are visible here, and we can work in this way with the system. And yeah, I think the tool is interesting, and it's possible to be downloaded here in the website, which is at the end. And okay, then I will just finish my presentation, not to hurt the following.
Thank you very much, Jordan.
Thank
Let's
you.
give Jordan a virtual hand clap. If you have any questions for Jordan, please post them in the chat. And in the meantime, we now switch to the fourth presentation of this session by Untitled Ma. Very welcome. And the title of the presentation is Conceptual Design of a Nano-Satellite Incubator using Axiomatic Design and a Mechatronic Multi-Criteria Profiles. Can you please share your screen? Ciao.
Yep.
Yes.
Hello, everyone. So could you see my screen?
Very well. Thank you very much.
Thank you. Yeah. So hello, everyone. My name is Yuan Chao. And so to be sure, my presentation fits in the 12 minutes interval. I have pre-recorded my presentation. So just let me know. I will run my presentation now, and just let me know if you can hear the sound. Thank you. Hello, everyone. My name is Yuan Chao Ma. I'm currently a PhD student at Polytechnique Montreal, and I'm glad to have a chance to present you my master's work, which focused on the conceptual design of a miniaturized incubator for a nanosatellite mission. So the goal of space biology research is to understand the behavior of organisms in the space condition, especially the effects of microgravity and radiation as two important factors. And with the growing interest in long-term space mission, it is critical to improve our knowledge and develop ability to produce food of Earth. Furthermore, because of the low cost in terms of development time and budget, and also the advances in miniaturization of commercial off-the-shelf devices, the development of space missions based on the CubeSat standards has been facilitated and stimulated in recent years. And thus, Polyhabit, a technology association of Polytechnique Montreal, decided to conduct an experiment for plant growth on CubeSat platform to investigate how plant cultivation process will perform in the space condition. Thus, this project, our objective is to design and develop an automated autonomous incubator system for this mission. So, figure 2 here shows the design methodology and process. We have identified 2 major challenges to be handled in this design task. So given the multidisciplinary nature of the project, we have a wide variety of customer requirements that influence the designer to find the most suitable alternatives, and therefore its accurate interpretation into a specific design parameter is a major challenge. And to address this problem, we firstly use axiomatic design approach to generate different concepts and obtain different feasible concepts for the next stage. And also the CubeSat has multiple subsystems, and they're usually designed simultaneously. Thus, we need to consider also the compatibility between subsystems and their synergistic effects. And it is important also to identify and correct errors earlier in the design process to reduce the overall design cost. So we decided to use mechatronic multi-criteria profile developed in our laboratory for concept generation in the second step to generate the best concept for detailed design. Thus, here axiomatic design. So it is proposed by Xu in 1990, and since then it has been widely used to solve complex design problems. There are 4 distinct design domains: customer attributes, functional requirements, design parameters, and process variables, which the last one will not be considered in this study since we're only focusing on the conceptual design phase. And here, table 1, we start with coordinating and translating all design requirements into a customer attributes. Since our incubator will be a 1-unit CubeSat payload, the relevant constraints are indicated in CA1, and the rest, the experimental specifications are translated into a CA2. And here, figure 3.A shows the design domains involved in this study. So constraints represent the bounds on a acceptable solution stated by Xu. And so the subsequent analysis process and also the final generated concepts must respect these constraints. And then the definition of the first level of functional requirements is completed by an injective transformation from other customer attributes. So here on the right-hand side, we can then follow the independence axiom to derive the relevant subsystems and components with low coupling from the continuous mapping between functional requirements and design parameters. And also, Tan in 2009 pointed out that for one functional requirement, there may be more than one corresponding design parameters that may satisfy the functional independence axiom. And thus, the combination of these different alternatives with each other's becomes different design concepts to be evaluated in the next stage. So here we have the different commercial off-the-shelf device alternatives carefully identified by the designers, which also respect all the constraints previously identified, shown in the last line. And some of the subcomponents and were pre-selected or either will be customized because of its specific characteristics, and therefore these components are not considered to be evaluated in the next stage. So we have generated 64 concepts, 64 concepts in total. And in order to simplify the presentation, we choose 4 concepts to study, here shown in table 2, to demonstrate the MMP, mechatronic multi-criteria profile approach. So the next step is to determine the elite design by comparing the different sets of components. And in 2008, my colleague Dr. Moibi has identified the most important criteria and their associate subcriteria to form an index vector called MMP. So which includes machine intelligence quotient, reliability, complexity, flexibility, and cost of the system. So here we show you guys also the subcriteria of each criteria. And specifically here, we use full tree analysis approach to replace the original calculation process, as spatial systems require a critical level of ability analysis, and FTA is a more robust method. So a little bit of mathematics. Here we define xi as the parameters used in calculating a criterion or a subcriterion I, and then the normalization is done by the function f here. And with the value of each major criterion mi calculated by the linear summation using a weighting factor omega shows here. We can then calculate the global concept score GCS by the Schottky integral, which has two types of weighting factors: phi I, representing the importance of criterion I, and the IIJ, representing the interaction index between criteria I and J. So these two fuzzy metrics were obtained by questionnaire collection from 10 different researchers specializing in system design. They all responded to these 15 fuzzy measures, and then we aggregate the results as the results are shown in here, the table 4. So results and discussion. Here, this table gives the evaluation results for each subcriteria of the proposed concepts. And we can see here with the GCS, we can easily conclude that the concept 4 is the elite concept among these 4 options with a score equal to 0.89. And furthermore, by looking at this table, we can see that reliability and complexity are the 2 criteria recognized by the 10 researchers as relatively important in this design process. And meanwhile, the concept 4 also has a highest reliability score, and complexity indices confirms that a more reliable and less complex design is the ideal design. And also concept 4 performs quite well in terms of machine intelligence and flexibility compared to other concepts. And in terms of cost, our design was a single specific test, so this criteria was considered relatively the least important among the 10 respondents to the questionnaire, and thus its impact is quite limited within reasons. Finally, combining the result of axiomatic design and the MMP, the proposed system for the conceptual design phase is shown here in Figure 6, which is a pressurized and miniaturized incubator consisting of 4 different subsystems as temperature control system, cultivation system, inspection system, and supply system. Also, they answer the customer attributes we defined in the first step. So based on the results of this conceptual design, the team later performed the detailed layout design and also built a 1.1U proof of concept and 1.2U 2 units prototype that were successfully tested in plant growth experiments under terrestrial conditions to verify the feasibility of the design. And both the results have been published. So in conclusion, this paper presented the conceptual design of a miniaturized incubator using axiomatic design to translate project specifications into design alternatives and generate different design concepts. And then we use mechatronic multi-criteria profile to numerically evaluate these designs concepts and generate a best design solution for the detailed design. And the best solution is a pressurized microincubator with cultivation system, temperature control system, supply system, and inspection system. So finally, we would like to thank to the support of Canadian Space Agency for this project, and calculation details could be found in my master thesis if you are interested in. And if you have any other questions, feel free to contact me. That's all for today. Thank you.
Thank you very much. Let's give him an applause. And if you have any questions, Yuan Chao, please post them in the chat. And then we're thanking Yuan Chao. We move on to the final presentation in this session. It's the student presentation by Binosh Mishko, and please, Binosh, present your poster that's entitled RF Systems Engineering based on DSM analysis.
Hello everyone, can you hear me?
Yes, we can. Loud and clear.
Sorry, just a second.
Very welcome.
Can you
Please.
hear me?
Yes, we can. The poster is clearly visible.
Sorry, there is a little difficulty. Hello, can you hear me now?
We can still hear you. It's less loud, but still clear.
Okay, sorry for some technical difficulties here. And sorry for the confusion earlier. I started to present my poster. I mixed up the schedule a little bit. Hello everyone. Do you have my poster in full screen? Yes?
Yes, it is in full screen.
Okay. So I will start now.
Please.
My name is Behnush. I'm a double degree PhD student in Skoltech in Russia and ETS in Canada. And this is part of my PhD research about reconfigurable transmit array antenna and implementation of systems engineering approach such as DSM. So reconfigurable transmit array antenna is a complex antenna which is capable of modifying its radiation patterns using reconfigurable components within its system. So my research is aiming to make a bridge between RF engineering and systems engineering and present the complexities of such a system through DSM and presenting the implementation of embedded self-calibration in this system. As we can see in picture 2 in the top middle part, reconfigurable transmitter antenna includes several subsystems. It's a cyber physical system of systems, to be more accurate. It includes hardware, software, analog, digital, radio frequency, and baseband components and mechanisms within it. So we on the left side of the diagram and the second figure, we have digital processing, RF processing, and then the horn antenna, which is transmitting the incident wave to each of the unit cells in an RTA or reconfigurable transmit array antenna. Each unit cell is composed of a receiving antenna, phase shifter, power amplifier, and transmitting antenna. And an RTA can include several unit cells. For example, the system that I will do tests on, it includes like 50 unit cells. And normally in unit cells, I will just try to explain a little bit about the RF systems aspect of the project to make it clear that why and how DSM is going to help with the design. So within each unit cell, if we have a feedback from the transmitting antenna to the receiving antenna, that would be negative emergence. So this unit cell is isolated from other unit cells and even isolated from the output to the input. But if we utilize a novel self-calibration mechanism in this system and we incorporate behavioral model in the self-calibration mechanism, then we are applying intentionally feedback to the system to enhance the positive emergence of the general system. Because such a complicated system, we cannot tweak each of the subsystems to have acceptable functionality. Therefore, we consider one of the main subsystems, which is a phase shifter and power amplifier lineup. Here we can see them, phase shifter and power amplifier lineup. And then just tweak this part of the system and enhance the performance such as reliability, linearity, reconfigurability, and beamforming features. Figure 3 and 4, they represent the DSM of our system. So for the figure 3, I decompose the system up to 3 levels, but it can be decomposed further and further up to components level. But I'm not showing it here because the DSM is going to be huge, but that's the next step of the research. So here we see 3 levels of decomposition of the system. And as I mentioned before, feedback would be negative emergence. So main elements, almost all of the elements are below the diagonal. It's an IR convention DSM, and it's the structural architecture type. So all of the elements are mainly below the diagonal. But when we are implementing an external embedded self-calibration to the system, then we have some very few elements above the diagonal that are highlighting the feedback feature here. So in general, we receive the signal from the input and output in each unit cell and send it to a mechanism that includes the behavioral model of a typical power amplifier and phase shifter. If the behavior of the system is not as desirable as we want, then through feedbacks from digital processing and RF processing, we will start to implement self-calibration to power amplifier and phase shifter lineup. To wrap up the presentation, I can say that, so here we are dealing with a complex system that includes several types and various types of interfaces. For example, for this project, I identified 6 different types of interfaces: electromagnetic propagation, baseband, which is a low frequency and unmodulated signal, and then RF interface, which means that we have high frequency and modulated signals, analog, digital, and electrical interfaces. You can see several types of interfaces in the DSM. And then, so we're representing several types of interfaces, their conversions to each other, and to analyze the modeling, the design and test and functionality of this system. Figure 4 has can show the higher, like top level system view that we have, like digital beam, like it's more block based, that we have general blocks, digital beamforming, RF processing, and then I'm showing 3 unit cells as example here to represent the feedback function and self-calibration mechanism within the system. So this research is utilizing a novel self-calibration adjustment to the RTA performance. And this is a use case for the systems engineering approaches that we're going to use for this research. And I'm trying to make a bridge between RF systems engineering and systems engineering. And DSM is used as a tool to represent the complexities of this system and several types of interfaces and interactions within the system. And for the next steps of the research, I'm going to decompose the levels. So it will have 4 levels of decomposition up to component level. And the general aim is to provide a unique and comprehensive reference tool for the design knowledge management of this kind of complicated, complex system. Thank you so much for your attention. I would welcome comments and questions. Thank you.
Thank you very much, Binose. Let's give her a virtual hand clap for your contribution. If for this is, since this is a student presentation, we would like you to vote in the link that has been provided in the chat. I think Jacob posted the link. Is that?
Yeah.
Yeah, there is a link in the chat. Please use this link and give some nice scores for